dokie. So today we're going to go ahead and do a quick physics introduction to atomic structure, electrons, protons, and neutrons. So what I want you to do, go ahead and take a guess. What does an atom look like? So back from what you've learned in previous physics courses, if you've taken them before, or chemistry courses, take a guess, and then check back in on the video. Okay, so we know that in an atom, the center of an atom is the heaviest part of it. And the center of an atom consists of the nucleus. So this is the nucleus, which is the atom center. And the nucleus consists of a bunch of neutrons and protons. So a bunch of protons and neutrons in an atom. Okay, cool. So again, N stands for neutrons. And again, those are a neutral charge. And P stands for protons. And those are going to be a positive charge. So all around the nucleus is we have electron shells. So there are electron shells all around an atom. The first electron shell can hold up to 2 electrons, while the next electron shell, one right outside the first one, can hold up to 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. It might not necessarily hold 8, but it could. So again, the electrons are in shells around the nucleus. The neutrons and protons, keep in mind, those are actually going to have more mass than electrons. Electrons are not very massive. So let's say you rub, you rub a sweater or something like that. What is most likely to transfer, let's say you're rubbing your sweater on a wall or something like that, or a balloon on the wall. What is most likely to transfer from the wall to your sweater, or vice versa? Is it going to be electrons, protons, or neutrons? Well, think about it. Neutrons or protons, those are in the center of the nucleus. Those are not going to move. If a neutron or proton moves, that's going to physically change the structure of that atom, and it will be a totally different atom. So it is going to be the electrons that move. So electrons are transferred, and let's write this in a different color. So electrons are transferred between objects. Not protons. And again, those electrons are on the outer shell, so it's much easier to move. Okay, let's go ahead and chat a little bit more about electrons, protons, and neutrons, and the charge on each one. Okay. So a couple of just general things. So first off, is for charge, regardless of if it's a positive or negative, or I guess we'll say plus or minus, it's going to be Q. So Q is going to be the symbol for charge. So the symbol oftentimes used for electrons is going to be E minus. The charge on one electron, and again, are electrons positive or negative? Electrons have a negative charge, is negative 1.6 times 10 to the negative 19 coulombs. Or you could just say C. And again, a coulomb is a unit for charge. So now let's think about protons. So oftentimes the symbol we'll use for protons is going to be E plus or P. We'll see either of those. Okay, so if the charge on one electron is negative 1.6 10 to the negative 19 coulombs, a proton is going to just be the opposite. Charge on one proton is going to be positive 1.6 times 10 to the negative 19 coulombs. So essentially, if an atom has the same number of protons and electrons, it is going to be a neutral object. Neutrons, and I think of with the N, are going to be neutral. They will have no charge. Sorry about that. No charge. Okay. Okay, so I encourage you to try the 2 problems below yourself and then check back in on the video. And then we'll chat together. Okay, so let's look at the first one together. So we have an atom with 32 protons, 34 electrons, and 32 neutrons. We want to know the net charge. I should have added in this problem in coulombs. Okay, so let's think about it. If you have 32 positive charges and 34 negative charges, some of those positive charges are going to be canceled out with the negative ones. You're going to be left with 2 electrons left over. Neutrons are neutral, so those have no charge. So I'm just going to essentially cross those off. So what's the charge on 2 electrons? I can essentially set up a conversion for this. So it's like 2 electrons over 1. Let's see, charge on 1 electron is going to be negative 1.6 times 10 to the negative 19 coulombs. So electrons essentially cancels out. And that will be negative 3.2 times 10 to the negative 19 coulombs. And that is the charge on an atom with 32 protons, 34 electrons, and 32 neutrons. Okay, let's try another example. So we have a plastic rod. It's charged to 8 Nc by rubbing. Okay, the N right there stands for nano. Nano means 10 to the negative 9. Another symbol that we're oftentimes going to use in different problems is going to be mu, which is micro, which stands for 10 to the negative 6. And again, I think of like nanotechnology, that's pretty small technology. Micro, micro something is pretty small as well. So these are very small numbers we're dealing with. Okay, so plastic rod is charged to a positive charge by rubbing. So have electrons been removed from the rod or protons added? Okay, protons, again, those are in the center of the nucleus. Those cannot be like added or subtracted unless we're going to like do a bunch of crazy stuff and we're changing the atom entirely. So it has to be, electrons have to be removed from it. Electrons are the things that transfer. So let's think about how many electrons have been removed. Okay, so the charge is 8 times essentially 10 to the negative 9 coulombs. So we need to figure out how many electrons this is. So let's go ahead and set it up. So I know from up here, I know that 1 electron is negative 1.6 10 to the negative 19 coulombs. And again, the negative is just there to say it's an electron. So I can just set that up as a conversion. The 1.6 times 10 to the negative 19, that goes with the coulombs, and it's for every 1 electron. Okay, so coulombs cancels out, left with electrons. Make sure when you plug this in the calculator, you use parentheses for that bottom part. And I got 5 times 10 to the 10th electrons. Awesome. Thanks so much for watching this intro video.